about. There are some seats here if you want. If you want to get comfortable. This talk is about Kanban and metrics. So let me just ask you a couple of questions to get an idea of who we have in the room and also to keep you awake after lunch. This talk is full of numbers and charts, so what could go wrong after lunch? Who here has used Kanban or has at least some idea of what Kanban is? Okay, almost everyone, great. Have you used some sort of metrics like a cumulative for diagram maybe, or a lead time distribution? Who has? Okay.
Try to really understand it.
Great, so you're in the best place because I'm going to tell you all about it. My name is Mattia Battison. I'm originally from this little town in Italy called Verona. You might know it because of Romeo and Juliet. It's a lovely city, but everything about Romeo and Juliet is actually fake. But it's still lovely and the food is great, so you should be there at some point. I work in London for Sky in a department called Sky Network Services. We are the guys that deal with telephone and broadband. Usually when my wife asks me what I do, I tell her that we make the internet work. Most of the days it works. Over there, my background is software development, but I do a bit of agile coaching-ish, like I help teams improve. This presentation is a public version of what I do internally for teams that want to get started with metrics. It's the experience from my team about what we do and how we use metrics to continuously improve. I always give this little disclaimer first that you want to have a bit of an idea of what Kanban is before you get into metrics, but the level in the room seems quite high, so we should be fine. If at any point you have questions, feel free to stop me and I'll clarify. So I always like to start with why. Why do we need metrics? What problem are we trying to solve? Why bother? In my team, we use metrics for these two reasons. First one is that we use metrics to drive our continuous improvement process. One of the Kanban practices says evolve experimentally. So we use metrics to get an idea of where we need to improve. Then we introduce a little change, some sort of experiment, and we use our metrics again to verify whether the experiment has been successful or not. Was this change beneficial or not? It's a constant feedback loop that we get. And the second reason is that we use our data to forecast the future. So we collect a lot of historical data and we use it to make predictions, which has really improved a lot our predictability. I'm mostly focused on this half today, on the continuous improvement, but I'm happy to have a chat about the forecasting if you want. So chances are that even your reaction when I start to talk about metrics is, how about no, thank you? Because we've all seen metrics gone horribly wrong in the past. Remember what happened with the velocity, right? It seemed like a great idea for the first few years. Then managers started to demand that teams reach a particular velocity, and the teams started to understand, hang on a second, I can just double the points of each story, and it's going to look like I'm going down as fast. And we get a big bonus, party, everyone's happy except the customer. So that is the problem with most metrics. It's not just that velocity is not bad, it's not bad per se, but the problem with most metrics is that they're very easy to gain, and you can end up causing dysfunctions if you're not careful. That's why with my team we created this sort of checklist of what we consider good and bad metrics. We consider something to be a good metric if it looks at improving the whole system rather than rewarding or punishing individuals. You might have heard this quote before. This gentleman, Devin, studied the Toyota production system in the 60s and 70s and basically brought it to the Western people into what today we call lean. And in his studies, he found that 95% of the performance is attributable to the system and only 5% to the people. Which means that if you're serious about improving, if you really want to improve, you can't just tell the people to work harder or to try their best. Because, well, first of all, they're already trying their best, probably. But even if they manage to improve, they can only have a very small impact on the overall performance. If you really want to improve your performance, you need to change the process around the people. Give them an environment where they can do their best, remove impediments for them, find out what is preventing them from being awesome. So good metrics help us improve the process rather than blaming individuals or rewarding them. We never use our metrics as a target. We're not interested in reaching a particular number. It's just a feedback that we get about reality. Are we improving or not? But that's all we're interested in. It's more about the trend rather than the actual number. As much as we can, we prefer leading indicators because we want to know about a problem, why is it still happening, so we can do something about it. And it's only when all metrics are improving that we are happy that we consider ourselves as improving. If you focus on only on one metric, you quite quickly fall into local optimizations. Right, so before I go into the details of the metrics that we use, let me tell you a few words about how we work. This is our main work. Stories enter our process in this column that we call next. Notice these colored cards. Those represent our week limits. So we actually have some placeholders, and you have to put the card in one of the placeholders. So that's a week limit of 3, week limit of 2, and 3 over here. So when a story, notice that here we only want the next 3 top priority stories. And whenever a slot here is empty, we have a conversation with our stakeholders, our BA, and decide what is the next top priority. And this is what in Kanban you technically call your commitment point. It's when a piece of work changes from being an option in a backlog to being the next thing that you're going to work on. And this is quite important because that's when your lead time starts. When you've decided that this is the next thing I want to work on, that's usually when the clock starts ticking. Then stories go through development and testing, and into this column that we call waiting for cut. Now, some of our code bases have to be released with some downtime, so we only release them during the night, only once a month because it's so expensive. So for those applications, stories have to wait there, and then at the end of what we call an iteration, we do a cut. That cut goes through release testing, and then it's released to production more or less after a month. But for more modern applications, we can release on demand instead. And we also have some stories that we call direct. They go straight from development to done, because they don't really require any testing or they don't need to be released. It's just stuff that has to be done, like answering an email or creating a report, stuff like that. I'm telling you this because these 3 arrows are what in Kanban you call 3 different work item types. There are different types of work based on the fact that they might not follow exactly the same process, or they follow the same process but at a different speed. This is really key because most of the metrics only make sense when you look at one individual work item type. If you take these stories, well, there will always be about a month of wait here. So there's no point comparing the lead time of these stories with these ones that instead we can release on demand. So this is really a key point to take away from today. Most of the metrics that we use, and that I'm going to show you, you have to use them on an individual work item type. So you have to split them on individual work item types. This is how we collect our data. We print our cards usually, and at the bottom we have this grid where A, B, C, D, they all represent one column in our process. What we do is every time a card moves from one column to another, we stamp it. We bought a little rubber stamp from Amazon, and we mark the day when a card moves from one column to another. So we are recording the transitions between the states in our process. That's it really, that's all the data we need. Because with this little amount of data, we know exactly how long a story has taken from start to end. We know exactly how long the story has spent in each state. And we can even go back in time and find out exactly what was happening in any point in time. And on a regular basis, I take those dates and put them into a spreadsheet that I use to analyze the data. When I publish the slides later, you will get this link, so if you want to take a look at what my spreadsheet looks like, feel free to do so. But yeah, really that's all I have to do. I get those dates, put them into the spreadsheet, and then it generates all the metrics that I'm going to show you. Usually at this point someone asks, oh, why don't you use Jira? Or why don't you use this particular tool? We do use Jira actually for recording, having an electronic version of what is happening. And I did try quite a few tools that are available, but I still prefer a spreadsheet for two reasons, or two problems that most tools have. When it comes to recording the data, the problem with a lot of tools is that there are some things you can't do with the tool. So the data that you're recording is not really reflecting reality. So you end up having data that you can't trust, really. And the second problem is that when it comes to analyzing the data, then most tools do one or two diagrams quite well. Jira does a couple of them, but they can't do everything you need because, well, you don't even know what you need. This is some sort of data mining exercise, so I still want access to the underlying data to generate everything I want. Having said that, if you do find a tool that works for you, that's great. I found for my team that a spreadsheet gave us the best balance between flexibility and having to maintain it. The math involved is really simple. I'm not going to explain it because I'm sure you remember it, but it's here if you want to do it later. So, first metric that we use, it's probably the most famous one that you see in the Kanban community. It's called Cumulative Flow Diagram. And it works like this. You've got days here, and for each day, you're counting how many stories are in each state. So on this particular day, we had 2 stories in next, 2 stories in development, 1 story in testing, 4 or 5 stories waiting for cut, 3 stories in release testing, and a bunch of stories that were already done. And you do this for each day, and you get this sort of diagram. This is all about flow, hence the name Cumulative Flow Diagram. It's about spotting whether you have a good flow in your process. Are stories moving smoothly in your process? Do you have blockers? Do you have stories that stay there for a long time? An ideal theoretical CFD would look like this. You have thin lines that grow in parallel at a steady rate. This would mean that every day something is going into done and stories are moving regularly to the next state. Yeah.
So don't mind if you mind interruptions. Yeah. So what you're looking to avoid is horizontal regions on the CFD.
I'm going to show you some examples in a second. Well, theoretically, this is what the best CFD would look like. In real life, it's never going to look like this. But the problem with this is that even though it's so famous, you see it done even in Jira. People find it quite hard to read, especially people that are new to using these sort of diagrams. So let me tell you how we use these things. We have used CFDs in retrospectives. This is from a point in time when we only had 1 tester. So I hope you can see the trajectory is not great. But you see this big bunch of blue going on here. That's the only tester that was doing release testing. He was busy doing release testing. So on top of that, you see this light green area that grows and grows and grows. Those were other stories that were accumulating because the tester was busy and he wasn't available to test them. And at the time, the test manager had a policy that only testers can do testing. I know. So after we managed to fix the problem, we had a retrospective with this test manager and showed the effect of his policy, and we convinced him to change it. Now developers are more than welcome to swarm around testing and help. We have used it to validate our experiments. So if you look on the left here, you see that the lines are quite flat. We didn't have a very good flow. At the time we had 6 developers, but we always do pair programming, so that makes for 3 pairs. What we did is we changed our WIP limit in development from 3 to 2. That might sound crazy, but we always had 1 spare pair of developers. And what that pair was doing is dealing with interruptions or focusing on helping stories move forward in the rest of the flow of the process. And you see what happened to the flow. The flow is now going up at a much nicer rate because this extra pair was focused on helping other people finish what they were doing. We have used it to decide what to work on, and there are about 1 million articles online that tell you how to get the lead time, throughput, all this information. You can read them from a CFD, but if you're collecting the data that I showed you earlier, there are actually a lot easier ways. There are easier ways to get this data rather than read them from a CFD. So to answer your question, because it's so hard to read, we created this kind of cheat sheet of what are the common patterns that you can see in a CFD. These are taken from this really good article by Paweł Polzinski. It's quite big in the Kanban community. And just to mention the most common ones, when you get lines like that that start diverging, that means that you're starting more work than you're finishing. That's probably an indication that you need WIP limits. When you see steps like this, that's an indication that you're releasing a bunch of stories at the same time. So maybe you're not releasing often enough. Maybe you need to start doing something about continuous delivery. Flat lines, that's the worst enemy of flow. That means that stories are staying in the same state for a long time. We printed this slide and we keep it next to our board so that we have a quick reference of what we're looking for. Does this answer your question? We then look at some metrics for our delivery time. And this is another really famous one called control chart. If you've done some Six Sigma in the past, you might remember this, but it's slightly improved. You might see it done with dots usually, but in my spreadsheet it was easier to use columns, so don't mind that. Each column here, each bar, is telling me how long a particular story has taken. So this one has taken 3 days, this one has taken 5 days, 5 days, and so on. So it's the lead time of each story. And then in green I've got the median, which happens to be 4 days. And these 2 red lines, they are telling me that 25% of our stories take 2 days or less. And 80% of our stories take 7 days or less. So whenever a story falls outside those red lines, when it falls outside those boundaries, like this one or those ones, those are very interesting stories. There's something unusual about them. They either took longer than usual or shorter than usual. We usually talk about them in retrospectives. What happened? What made this story longer than usual? What did we do wrong that we can avoid next time? But also we talk about the good stories. Why were these so fast? What did we do well that we can maybe replicate again? This is really a great chart to bring into a retrospective to give you ideas and finding opportunities for improvement. But once again, remember, this only makes sense if you're looking at one work item type. You will have one of these for each type of work that you do. And we then calculate some stats about our lead time, median, standard deviation to get an idea of how much variability we have in our system, and some percentiles, but I'll explain them in a second. But what I wanted to notice is that we have an all-time view and a since a particular point in time. You don't want to use data that is too old. If you're really doing agile, Kanban, continuous improvement, ideally your process should always be improving and changing. So data that is too old ideally is not representative of your current process anymore. So usually I look at about 5-6 months of data and I move the rest somewhere else. I back it up somewhere, but I stop taking it into account. And I also like to plot our lead time as a trend to see whether we're improving or not. So I can see that our lead time has been going down regularly. And this is what people find very useful often, the lead time distribution. Over here, we are counting how many stories have taken how long. We've got 17 stories that have taken 1 day, 17 stories that have taken 2 days, and so on. So you're counting the frequency of every possible lead time. And it turns out that this is a particular type of distribution called Weeble distribution that has some theoretical implication, but it's a lot easier to understand with this data on the right. Because I know exactly how many stories have taken how long. % stories take 1 day, another 11% stories take 3 days, and so on. So I can do a cumulative sum and tell you that 52% of the stories take 4 days or less, and 81% of the stories take 8 days or less. Having this data really changes the type of conversations you have with your stakeholders, because when a project manager or a business analyst comes to us now and says something like, I really need this story done by the end of the month, it's really important, then we can say something like, well, if it's really important that it gets done in time, we should start it 8 days in advance, because that way we are 80% confident that it will be done in time. Or we could start it just 4 days in advance, but we only have 50% chances of getting it done in time. So it changes the conversation from giving an estimate and then blaming people if they're wrong to how important is the story? Can we afford not to get it done in time? And by the way, having data like this is also a step that you can take toward a technique called probabilistic forecasting, when you stop really estimating in the common meaning of the term, and you use your data instead to predict how long things are going to take. So this data is great, but it tells me about the past. It tells me how long things have taken in the past. So to know about things that are currently in progress, we take that data and we came up with this concept of story health. We look at the stories that are currently in progress every morning and say, well, if they've been in progress for 0 to 4 days, that's okay, because at least 50% of the stories take that long. But when a story goes on the 5th day, it's now starting to take a bit longer than usual. So we highlight it as yellow and we start asking questions. Well, do we need to swarm on it? Do we need to remove some impediments? Is everything okay? Then if it goes on 8 days, then that's really alarms going on, because it's starting to take longer than 80% of the other stories. So we use this data at stand-up to decide what we should work on, what should we give priority to. And this is quite specific, but it's a great example. I mentioned that some stories don't get released immediately. They have to wait until a particular day of the month. So for those stories, we keep track of how long they took in green to be done, to go through development and testing, and then in red, how long they actually took to be deployed to production. And it's really scary because it's telling me that 86% of the time the story is just waiting for a release when it could be already in production delivering value. And we use this data to have a discussion with release managers and just, drive our continuous delivery process. And that's why every new application now in Sky goes for a continuous delivery approaches. That sadly this is still valid for our legacy apps, but we're working on it. We then have some metrics for predictability. The most famous one, the most important one, is called throughput. Now, we use Kanban, but we still refer to a period of 2 weeks as an iteration. So the throughput works like this. You're simply counting how many stories are done in a particular period of time. So how many stories are done in an iteration or in a sprint. Again, you have to divide by the work item type, but having this data, I can tell you that 80% of the time we get at least 2 stories done, and 50% of the times we get up to 4 stories done of this particular type. So let's say you were in a sprint planning meeting and you have to decide how many stories should I pull into the sprint. Well, you know that most of the times you get done only 2 to 4 stories, so there's no point really talking about the next 10 stories because you will never get them done. And once again, this data is great to make predictions in the long term using we visualize these predictions with something that we call rolling wave forecasting. If you have some project management background, you might remember the rolling wave planning. This is similar, but now using our data. So let's say you have a prioritized backlog. Next to the backlog, using the information about our throughput, we visualize that these 3 stories, we have 80% confidence that they will be done in the next 2 weeks, so they will be quite certainly be done. These set of stories will probably be done. Possibly we will get to these ones, but it's very unlikely that we will get to story number 9. So it's a visual way to show to your stakeholders what you think you can achieve based on actual data that you collected in the past.
Does all of this really rely on stories being roughly evenly sized?
Right, thank you for asking that, because I forgot to mention it.
You're welcome.
So there is this myth in Kanban that stories have to be the same size. It's actually a myth, because as long as you're looking at one item, work item type, the size of the story doesn't matter because they will follow the same distribution. And actually that is a great question because it perfectly leads into this. Most people that are doing Agile have probably been taught that you should use some sort of story points technique or t-shirt size, something like that. And that's what we were doing in my team when I joined. We were doing planning poker. So for a while I kept track of how long things were actually taking. And I found that stories of 1 point were taking from 2 days to 10 days. And stories of 2 points were taking from 2 days to 20 days. Stories of 3 points were taking from 5 days to 18 days. So I found very little correlation between the actual size of a story and how long it actually took. Now, just to be clear, I'm not telling you that this is your case. You might be using story points very happily and they might be working great for you. But a lot of people in the Kanban community and in the Agile community are finding similar results and are stopping to use story points, relying instead of actual data and what I've been showing. An analogy that I love to explain this is that imagine that you're on a motorway and there is traffic, lots of traffic. So what happens is that in that case, the big lorry, the Ferrari, and the little Fiat 500, they all have different sizes, but they're all stuck in traffic anyway. They all move at the same speed, which is very slow. But this is so what does this slow correlation mean? It means that the size of a piece of work, it does have a little impact on how long it takes, but there are other things that have a much bigger impact, in particular the amount of work in progress that you have.
So what sort of conditions would influence your decision as to whether or not to go with story pointing?
I couldn't hear you, sorry.
So what would inform your decision as to whether or not to use story points?
Yeah, well, when I joined the team, they were doing it, so I went along for a while and I was tracking some data. After a while, I had this data showing that the story points that we were using really had no meaning. It made us not predictable at all because stories of 2 points were all over the place, for example. So that for us worked as a shock effect, and we decided to stop spending time assigning points to stories.
That's it. I mean, you have got a high level of sort of variance there in terms of lead time. I guess my thought process is, so quite often with teams I do high level estimating. 95% of the time the teams come in pretty aligned to where we thought we were going in terms of those high level estimates. So I'm sort of challenging myself in terms of the value of the lower level estimating. My observation from looking at your previous graphs was that you still had quite a high level of variance in lead, in terms of lead time. You had like 100% variance, and actually, it's just interesting that you still have those parallels between story points and lead time in terms of accuracy.
Indeed. So that's why we said, okay, let's not. So the time that we're spending assigning a number in points to the stories is not actually giving us any value. We still have what we call estimation sessions, when we get a piece of requirement and break it down into stories. But then that's all we do. Once we have the number of stories, we use the data about our throughput to do what is technically called a Monte Carlo simulation, and you get you're simulating how long a project is going to take, for example. It wasn't adding value for us, so we stopped.
No, I agree.
So the size of a story for us has little impact on how long it takes. So we prefer to keep track of the amount of work in progress to make sure that it stays in a range that we're happy with. So most of the times it's between 3 and 5, and that's something that we're okay with. But if we saw a trend going up or down, we will start asking questions. A little fun way of visualizing your data and your predictions is with what we call business stations. So, when you go to, who's been to Istanbul? Okay. Do you have feedback in Wales? Do you have something cool like that? Oh, good. I'll have to pay a visit. So you know when you're queuing and you see those signs that say from here you will wait about an hour, and then from here you will wait about half an hour. So on top of each column of our board, we have these little cards saying that from here it will take you 5 to 10 days to get it done, and you will probably stay in this column for 1 to 3 days. It's something that, again, it helps us at stand-up to decide what we should work on. Don't mind that aspect. To keep track of our quality, what we do is very simple because we don't have a big problem with quality. So all we do really is we count the number of stories and count the number of bugs. And when I say bug, I mean anything that is reported as a bug. It could be a complaint from someone, it could be a staff raise, it could be anything that is not expected. And we like to report it with this type, 1 bug every 6.5 stories. This is very useful when, let's say, you're planning the next 10 stories. Actually, you should keep in mind that you will have 1 bug every 6 or 7 stories. So instead of working on 10 stories, you will actually have to work on 11 or 12. So it helps us keep in mind that there will be extra work to do that we don't know at the moment. And finally, we have some metrics for our continuous improvement in general. This is my favorite one. It's called flow efficiency. You know, on your board you have some columns where someone is actively working on a story, like development. Someone is actually working on the story, development, testing. But then there are some columns where the story is simply waiting for something. It's in a queue, like next. The story is simply waiting for the developer to be available, or in between development and testing. The story is waiting for a tester to become available, and then it's waiting for a release to happen. So we consider those states when someone is working on the story as value adding, and the other ones as queues. And you calculate the percentage of how long you're spending in value adding state, and that's your flow efficiency. And it's very scary to find that 50% of the time of our stories is spent in queues. No one is actually doing anything on the story. The story is simply waiting, sitting on the board, waiting for someone to be available. And this is an example of what David was saying, that if you want to improve, you can't just tell people to work harder or blame them. You have to change the process around them to put them in a position to do better. Because by changing our process, we could eliminate this, or at least reduce this 50% time of wait, not by asking people to try harder. How do you reduce queues, by the way? Well, the first step is usually reducing your work in progress. But the ultimate solution is to have true cross-functional people. All this waiting time is really due to the fact that in our industry we love specializing people. We have BAs, we have developers, we have testers, and this causes the story to have to wait because of a handoff between a BA and a dev, and then the handoff between a dev and a tester. So, when one day we get to two cross-functional people, then this time will be really reduced. It's still my dream. And one day we will just be called team members instead of developers and testers. And last one, but it's really fun. You know when you're in a project that is late and your manager comes in and says, I'm going to give you more developers to make you faster. So this shows for each story how long the story has spent in each state, both in absolute time and in percentage. And notice that the development is the light blue one. The actual time that the story spent in development is very little. So adding more developers, yes, it might reduce the amount of blue time, after a while, by the way. But if you really want to improve your performance, once again, you need to change the process around the people. If you really want to have an impact on how long things take, we have to remove all the crap that is going on in the rest of our process. So quick retrospective to recap what I've just told you. We love our metrics because they help us understand where we need to improve, and then they validate whether we're improving or not. They enable forecasting for us, so we don't estimate anymore, but we rely on our data to make our predictions. They help us decide what to work on today, and the amount of learning that we get from this data is infinite. We can keep rearranging it and finding new interesting things from it. Please don't automate this too much, at least at the beginning. When you're starting to do this, you don't really know what you're looking for, you don't know what you're doing. So at least for a while, I would recommend that you collect this data manually and do it manually for a while, whilst you're getting confidence with what you're doing. Don't stress over precision. Don't ask people to write down the time when something moves. A precision of a day is more than enough. It's still better than any estimate that we might be doing. Only keep the last 6 months or so of data. Looking at older data is probably useless. And remember that you still need to trust the people. If they tell you something and the data tells you something else, the people are probably right. You might be doing something wrong with your data, but you might find some interesting insights. Problems that we had, it's very hard to get a team on board, especially at the beginning. I had to do this all myself for the first few months until I convinced them that, oh look, we don't need to estimate anymore, and then they were happy and got on board. Keep it simple if you can, otherwise when you open the spreadsheet or whatever, it becomes an information overload. We forgot to do this, that's why it was a problem for us. You should keep a diary of important events. So when you see changes in trends, you can understand what was happening that caused the change in trend. And finally, please keep in mind that you're dealing with people, so it doesn't matter how much data you have. You need to somehow translate that into feelings. I never managed to convince anyone just with data. I had to wait until they felt that there is a problem, and then I used data to tell them, oh yes, see that problem is here actually. A bunch of resources if you want to know more. And that's it for me. Thank you very much. Time for some questions? Yeah.
The page you mentioned that watch out, don't automate too much.
Yeah.
I really like this one. But usually, most company, especially when the company becomes a little bit big, from top management, they will ask for KPI.
Yeah.
So typical KPI is coverage in terms of unit test, manual, module test, integration, whatever test you want. Usually this is KPI from big boss.
Well, with automation there, I meant the collection of the data and generating the charts. I'm not really talking about automation of tests or anything like that. That is a whole different story. Sorry for the confusion. Okay, thank you very much. Well, I will tell you an idea of the data.